A new topic, differentiation. So first of all, we will understand the meaning of differentiation. If we have a function y is equal to fx and it is a continuous function in the domain of y, then we see that this y is dependent upon x. This dependency means that if you change the value of x, the value of y will change. So we can write that if y plus delta y is increment in y because of increment in x, that is x plus delta x. Delta y and delta x are increments in the value of y and x respectively. Delta y we can write is f x plus delta x minus y. So we can write this is f x plus delta x minus minus fx, because value of y is fx, so we have put the value of y, this is fx. So this is delta y. Now this delta y upon delta x will be equal to f x plus delta x minus fx. This is change in y with respect to the change in x. If we take this increment to be very small, delta x tends to 0, so we can put a limit over here, limit delta x tends to 0. So we should put the same limit over here, that is limit delta x tends to 0. This is called dy by dx. This is called dy by dx. dy by dx is derivative of y with respect to x. This is also written as f dash x and d by dx of fx. So this is the meaning of derivative, and a differentiation done with the definition of this derivative is called first principle differentiation. So we will solve some problems of first principle differentiation later on, then we will use this concept to differentiate. Now we have understood the meaning of derivative. Derivative is dy by dx, and if we calculate this value at a particular value of x, for example, if x is equal to a, if we calculate dy by dx and put x is equal to a, so this is derivative at a particular point. Dy by dx at x is equal to a. Now we can write this like this also, that f dash a. Now we want to understand the physical meaning of a derivative. So for physical meaning of derivative, we take a coordinate system on which we have x on the horizontal direction and y or fx on the vertical axis. Now if we have a curve fx, and this curve has a shape like this. So on this curve, suppose we take a point P. This P point has the value of x coordinate as x is equal to a. So this will have a particular value of function, that is suppose fa, and q is another point over here which is at a particular value of x is equal to a plus h. So this will have a particular value of fx, that is f a plus h. Now if we draw a line connecting P and Q, and we extend this line till x-axis, then this line forms an angle, suppose theta. So now we can draw it in the form of a triangle like this. Now suppose this point P has an angle theta and this point is Q, and suppose we take that this point is R. Okay, so this distance I want to calculate. This distance, this is PR, this is PR. Suppose I join it with dashed line. This is R point. I want to calculate this PR. This distance is A plus H. This is A. So this is A plus H minus A. So PR is A plus H minus A. So that is H only. And QR, this distance is FA plus H and this is FA. So this distance is FA plus H minus FA, this one. So QR will be FA plus H minus FA. Now if I want to write the slope of PQ, slope of PQ will be tan theta, and tan theta will be perpendicular upon base. So that is QR upon PR. So this will be QR is FA plus H minus FA upon A plus H minus A. So it means slope of PQ is equal to FA plus H minus FA upon H. So now what is H? H is increment in the value of X. X was A here and H is increment in the value of X. So we reach at point Q. And FA plus H is change in the value of F with respect to A plus H. So this value is FA plus H minus FA upon H. So this is actually slope of line PQ. Now, if we say that this Q point slides and comes over point P. So what is the meaning of Q coming on P? That is that this H will be 0 or H will tend to 0. So this Q is coming and sitting on P. It means that is H is equal to 0. So we can write that is or first we should see it physically. What is the meaning of this? If Q is coming and sitting on P, then that means that this line will be like this. This line will be like this. And this line is touching the curve at point P only. This line is touching the curve on P only. So it should be something like this. It should be something like this. Or let me draw it more clearly. That is, this was the previous line, and now this line is touching the point P. Okay, so this is actually, and it will have a different angle. Suppose that angle is alpha. So this will be slope of tangent at P will be limit H tends to 0 f a plus h minus fa upon h. So I hope you have understood this. Otherwise, I can explain it again. That initially there were 2 points P and Q. P was having x coordinate x is equal to a. With respect to x is equal to a, there is a particular value of fx, that is fa. Similarly, Q is another point which has the x coordinate x is equal to a plus h. With respect to a plus h, fx has a value a plus h. If we join P and Q point, then we get this chord. PQ is a chord. If we extend this chord up to x-axis, it makes theta angle with the x-axis, and the slope of line PQ will be calculated with the help of this triangle. This PR I have explained. PR is a plus h minus a, that is h. QR is f a plus h minus a. So we can calculate tan theta. This tan theta or slope of PQ will be this much. So this is f a plus h minus fa upon a plus h minus a. So this was slope of PQ. Now if this point Q slides on the curve and comes on P, so the meaning of this is that this h is getting decreased up to value 0. So we have put limit h tends to 0. The difference between P and Q was, if we see on x-axis, this difference was because of h only. If h is very, very small, tends to 0, then this Q will come on P, and we will put a limit over here, that is limit h tends to 0, f a plus h minus fa upon h. And now what is the meaning of this? If Q point comes on P, so this PQ comes like this. This PQ comes like this. So it becomes a tangent. It becomes a tangent on point P. So this is slope of tangent at point P is equal to limit h tends to 0, f a plus h minus fa upon h. So this is the physical meaning of derivative. I hope it is clear. Now